In this section, I want to talk about some of the validity issues that we face in experimental research. And I want to start with returning to this definition of external versus internal validity that we talked about earlier in this semester. External validity is based on the generalizability of results in the real world. So how much does this really represent what's going on in the real world? How much can we generalize it to the real world? Internal validity refers to whether the conclusions that we draw from the study, from the research, accurately reflect what has gone on in the study itself. Is it an accurate representation or an accurate conclusion based on what happened within the study? So it's not a generalizability, that's external validity, but it is internal validity. Some of the threats to causal validity, and we're talking about experimental design, and some of these apply to other forms of research. The first is that the control group represents what we call the counterfactual, or what the treatment group would be like had it not been exposed to the treatment. So some of the things that we have to think about then, as we think about this control group with being the counterfactual, we need to consider selection bias. And that's a situation in which the treatment and the control groups are not strictly comparable. And it usually is caused by improper randomization or differential rates of attrition. And that's called external mortality. If you have a study that goes on for a while, people will drop out of it. Or if you start with something that's not properly randomized. Remember, we talked about how sometimes bias is on purpose, but often in research methods, bias is just sort of an accidental outcome of problematic methods, or even just randomness, random error. We can also talk about endogenous changes, and that's one of the models that one of the things that we consider is maturation. And that's a situation in which which naturally develops in the attributes of the subjects that influence the difference between the post-test and the pre-test results. People may grow and change in ways that affect the results. In long-term experiments, this can be a really important problem. In short experiments, it generally takes the form of someone getting tired of the experiment, or bored, or hungry, or sleepy during the course of it. But someone can literally change because of external factors and so on, which leads us to the next one. External events like in history. So that's a situation in which an external event occurs during the experiment that might account for the apparent treatment effect. Historical events can occur during the experiment that confound the results. Another threat to causal validity is contamination. And that's a situation in which the comparison group somehow affects or is affected by the treatment group. Imagine that you are studying the effects of a new drug on people's ability to run fast. We conduct the normal experiment, and during the experiment, people in the control group notice that people in the treatment group are running faster than them. And as a result, people in the control group might compensate by trying harder or practicing more. And that means that somehow that treatment group that's getting those extra whatever it is that's making them run harder or run faster or do more exercise, the people who aren't getting that, maybe it's jealousy or something like that, they may try harder to try to overcompensate for what's they're not getting. Another threat to causal validity is treatment misidentification, and that's a situation in which the researcher wrongly interprets the effects of treatment. This can occur if researchers expect the treatment group to perform better and then influence them to do so, or if subjects think they're receiving treatment, but they aren't, like the placebo effect, or if subjects simply do better because they're studied or observed, which is the Hawthorne effect, which we'll talk about a little bit later. So placebo effects, this can work in the opposite direction, where respondents become demoralized because they aren't getting a treatment and they do worse. Somehow they figure out that they are on the placebo, or they believe that they're on the placebo, and that mental issue, sort of that disappointment of it can actually affect their health. And so they may report more side effects or lessened impact. So they may actually be on the experimental drug, but they may think they're on the placebo. And that negative thought can actually have consequences, which affects the outcome. I'm going to come back to talking about the Hawthorne effect a little bit later on, but I'll move to talking about testing effect. And testing effect is a situation in which the act of testing and retesting can influence behavior. And these are similar to the priming effects that we talked about when we talked about surveys and how you arrange survey questions. If I ask you a question about crime early in the survey, I've primed you to thinking about crime. And so later, when I return to the issue of crime with an additional set of questions, it could impact the way that you think about it. I think the example that we used in the survey that you guys worked on was taxes. So something was going to increase your taxes. And then later on, we ask how you should pay for it. And of course, you're going to say, not me and not through taxes, because I don't want my taxes to be increased. So we primed you to be thinking about taxes as a possible issue. So the process of testing and retesting influences people's behavior. It can create sensitivity to the issue. It can, it may change their responses to make them more thoughtful of their answers. It can also result from regression to the mean for extreme cases. And so that statistical regression I'll talk about just a little bit. If we start out with groups that have extreme scores on views or an issue or a topic, that may bias your results. So you may want to study a program for teenagers who have extremely low math scores. These students can only stay the same or improve, meaning that even small amounts of stimulus are likely to improve the scores because the score started out so low. They can't get worse, literally can't get worse. So you may erroneously attribute the improved scores to a sign of the program's success when it's really just being exposed to math or getting any extra tutoring or whatever the program is. It would have that effect regardless because of just greater exposure and not actually a sign that your program is successful and should be continued or expanded. There are also some issues with experiments and external validity. And this is the biggest sort of weakness, which we'll run through again, of true experiments. Generalizability is frequently difficult because subjects aren't usually randomly selected. Some research designs try to maximize external validity in other ways, usually by trying to refine the treatment effect. But repeated experiments with different samples can improve external validity. So if we do the study over and over again and we find the same kinds of results over time, then that adds a little bit more generalizability to it. And researchers can also use experiments to generalize to theory, maybe not to populations or behaviors or patterns or the general population, but they can generalize to theory that can then be used to generate more refined studies later on or more refined explanations. Another source of external invalidity is testing interaction. And that's if there is an interaction between the testing situation and the stimulus. As an example, the Solomon 4-group design was created to deal with this kind of a problem. And so I'm going to show you the slide and talk a little bit about the 4-group design, but this is basically what happens. You have 4 groups that it's essentially like running the study 4 different times using the different models. And in doing so, any differences between the outcomes of all those models allows you to see what's the treatment and what's the model, what's the effect of the model itself. So for group one has both a pretest, a stimulus, and a post-test. So we're using an example of doing a pretest about prejudice and then showing a film that might affect someone's views and then giving them a post-test. So group 1 has the pretest, sees the film, does the post-test. Group 2 has the pretest, doesn't watch the film, and takes the post-test. That's your sort of classic design, right? Pretest, post-test design with a control group. But what Solomon added when he was working on his studies to try to deal with the effects of repeated testing and the notion of generalizability was that he added 2 additional groups. So he added a group that saw the film and got the post-test, but no pretest, because any differences between group 1 and group 3 that go beyond, right? You could say, okay, one of these is because they had the pretest. So this measured difference is because of the pretest, because the other group didn't have it. And then you have group 4, which is another control group, and all they get is the post-test. And they are essentially a way to check against the impact of repeated testing, right? So it looks sort of complicated, But the idea is to try to control for some of those areas in which we know that the circumstances of the study and being researched itself can have an impact on the outcome.